Twist it!
Young man, kill yourself!
Here's a quick showcase on how I modified a bop it and recreated the game's logic. So, this is a bop it. I'm sure at least 90% of you know what it is. But the gist is, the device tells you a prompt and you have to respond to that prompt within a given time frame. Bop it's input detection is actually just 3 buttons connected to the main circuit board. This makes it extremely easy to modify. The pull it button is activated by a small plastic widget getting pushed into the button. The twist it button is actually activated by a lever. It is under the board, so twisting results in a plastic widget applying pressure on the button. The bop it button is just a button, nothing special. By connecting these buttons to a microcontroller, we can read when they are being pressed, and we can send this information to a Python program via serial, which is essentially just a messaging system through the USB port. The microcontroller will handle all input logic, while the Python program will handle all game logic. The Python program starts in an off state. In this state, the program will do nothing but wait for a message from the microcontroller. Similarly, the microcontroller starts in a state of doing nothing but checking for button input. Once picked up, Python will start the game logic by updating the game state to on. From then, it'll be stuck in the gameplay loop. The loop starts by selecting either bop, twist, or pull, and then sends that prompt to the microcontroller and plays the corresponding sound. The program will then wait until another message is sent. On the microcontroller side, the what prompt function picks up the serial message and the prompt function is activated. The prompt function starts by marking the current time and then checks for input until either the time window runs out or any button is pressed. Then, based on whether the prompt was bop, twist, or pull, it checks the appropriate requirements, and if the requirements are met, it marks it as a success. If the prompt was successfully responded to, it'll send success to the serial and increment the success counter. If the prompt wasn't successfully responded to, it'll send fail to the serial. Finally, it'll update the time window and reset the prompt and inputs, ending the prompt and resetting the microcontroller. Back to the Python program, it'll either pick up success or fail from serial. If the response was success, it'll play the corresponding success sound effect and increment the score. If the response is fail, then it will play the fail sound effect, set game state back to 0, which is the game state waiting for user input, and reset the score. Finally, depending on game state, it'll either update the score and time window calculation, and then sleep for the duration of the time window, or wait for 2 seconds to give the player time to realize they've lost. Here's a quick run through with the active code displayed on screen.
Bloody hell, here I go again.
Bop it! Twist it!
Young man,